For the stacking cups, you'll see this title, okay? And this vocab will take us through a lot of the stuff that was on that second page yesterday. So hopefully your mind was wondering about how some of that stuff worked, and we're going to figure it out by going through this stuff today. Now, be aware that in the note guide, we kind of put a lot of stuff. We don't go through it all. The stuff we don't go through means it was in there as kind of extra that we could do. If we're not getting to that, you're not having homework on that specific thing. If you're not going to be quizzed on that specific thing. You're not going to be tested on that specific thing. Okay? I say that because this first section isn't really our focus. It's really the second section. So as you guys were reading, you should have figured out that a sequence is just an ordered list of numbers. Okay? They don't have to have any pattern to them. They can. They can't. But the list itself is just called a sequence. Each piece of the list is a term of the sequence, okay? So a term is one specific number in the list. The list itself is called a sequence. If you guys kept going on that worksheet, you then got to stuff about formulas, okay? Before we talk about those definitions, here is the notation, and there's a box for notation there if you need to write some of it down. So when we look at a sequence, here's my list of things, right? Okay. And notice that when we're specifically working with sequences, the notation they like to use is this A. If you are trying to find an A in this world, you are trying to find a term of the sequence, one of the numbers that is in this list. Okay? Is that all right with everybody? The little subscripts attached to the A are to differentiate which one we're talking about. So this right here, somebody would call this mathematically A sub 1, like with a subscript of 1. But you know how mathematicians, everything's abbreviated or there's symbols. So this is A sub 1, and that means the first term. This is A sub 2, and that means the second term. A sub 3, that means the third term. When they use A sub n, either they just haven't told you which term they want you to look for or you're trying to solve it, or they're just kind of referring to a term in the list in general, okay? Either because you're going to solve where it is, or they're giving you a rule, which we'll see in a little bit. So is everybody okay with notation and the word sequence and term? Any questions about those ideas? Okay. So the next two things up here are about formulas, okay? If the sequence does have a pattern, then there's a rule that it follows, okay, or a formula. So the formula and the rule are interchangeable words, okay? So if you have to jot that down, formula might also be seen as rule in certain places, okay? There's two ways that we look at it, explicit and recursive, okay? So who, after looking through the second page yesterday, thinks they understand what recursive means? No? Yes, Julie? Perfect. Okay, so a lot of you guys with the cups yesterday, your rule was every time you stacked a new cup, it increased by 2, right? So when you listed the cup heights out, you had numbers that were different by 2. And some of you had 2.5 or 2 1/4. Some people had 1.9. Just depended on your human accuracy and the shape of your cups probably, okay? But so if every time it went up by 2, that meant some people had lists like 14, 16, 18, 20, etc., okay? The up by 2 part is the recursive rule. The recursive rule or formula relates each term after the first term to the one before it. So it basically says, oh, you want to find the 5th term? Take the 4th term and add 2 to it, and then you have the 5th term. So something like adding 2 is a recursive rule, okay? Then what is an explicit rule or an explicit formula? Yes? Okay, so when things don't show up where you can necessarily say the same thing happens each time, you might have to write an explicit formula. You can actually write an explicit formula for the ones that just add 2 every time. Think about this. What if I asked you guys to find the 1,000th term in the sequence? And I told you that all you had to do each time to get the next one was to add 2. You had the recursive rule. right? What would you have to do to find the 1,000th term in the sequence? Okay, so he's trying to come up, he's like, if I know the difference is 2, I'm just going to add 2,000 to it and see. All right, we'll come back to that theory and see if it's right. So you're building an explicit formula in his head. He's trying to build an explicit formula in his head. Why would he want to say, like, I would just add 2,000? If you just used the recursive rule and you wanted to find out the 1,000th term, what would you technically need to figure out the 1,000th term? The 999th term. But what would you need to know the 999th term? 998th term. So if you relied only on the recursive rules information and no mathematical awareness of how that idea is going to pan out later, you would literally just have to write out the sequence, all 1,000 terms, okay? No fun. So what we want to do is what he was talking about. We want to develop some mathematical algorithm where I can just say, oh, you want the 1,000th term? Let me do something with 1,000 and tell you what the answer is going to be, okay? That's what an explicit rule is. An explicit rule lets you plug in the term number and figure out which term sits in that spot, okay? All right, so here is one example. I kind of already did it. It's quick. And this is actually the only example we're going to do in the first section. You guys are going to be like, but you had other examples on the note guide. I know, okay? Our focus is specific types of sequences, and we're going to talk about those. So here's a rule. What kind of rule is that? Explicit or recursive? Explicit, because I'm going to find a term. They didn't say a sub 1 or a sub 3 because they're saying, hey, you can find any term in this sequence. Any n you want can go there. And whatever which one it is that you're looking for, you need to plug that n value in this rule right here, and you'll figure it out. Okay? So when they say find a sub 9, they're really asking me to find the 9th term. And because I have an explicit rule, I can plug 9 in for n and do a calculation, which tells me the 9th term in this sequence that they're talking about that follows this rule is going to be the number 111. Is that okay with everybody? So it would be something, comma, something, comma, something, comma, something, and in the 9th spot would sit 111. Okay? So is everybody okay with notation and the difference between the meanings of recursive and explicit? Yes? Okay, so yes. Sure. Uh-huh. Okay, so recursive and explicit describes the rule. So if you wrote the rule in the format that says, well, you take the one before and you do this to it, then you're writing a recursive rule. Otherwise, you're writing an explicit rule. But that example would be really hard for us to do either because the rule changes depending on where you are. And so that one might require multiple rules, and you might have to say, you use this rule if you're trying to find like the first term, the 4th term, the 8th term, because they're going to follow a certain pattern, but a different rule when you're finding the ones in between because you had a different difference between them, okay? And this comes in with what we want to study specifically. In our course, we specifically want to study arithmetic sequences, okay? It looks like the word arithmetic, but it's pronounced arithmetic. I know, kind of weird. Okay, what makes a sequence arithmetic? Does anybody know the word I'm talking about, or you Googled something on your worksheet and you figured it out? Yeah. Uh-huh. Perfect. Okay, so to be not just a sequence, but to be labeled as an arithmetic sequence, you have to have the property that the way that your terms go in the pattern is by adding or subtracting something. So if I start with 5 and my next one's 7, I got there by adding 2. If this sequence is arithmetic, the next one is going to be 9. And the next one's going to be 11 because I'm not going to vary from adding 2. So if we add or subtract the same amount every time we change terms, that makes a sequence arithmetic. So you're not going to like this, but turn the page in your note guide and leave the rest of those examples blank. I know it's hard for you. Don't worry. I'm not shorting you curriculum. You don't have to do that. We put that in as extra. Okay. Oops, you can't see it that well. And all the definitions, you guys, that are posted up here all the time, they're in your book, okay? Yeah. No. So really good point. So he goes, what if it goes 2, 4, 8? There's a clear pattern there, right? Like timesing things by 2. That is not arithmetic. That actually, we're going to learn about that second semester, is called geometric. Okay? The reason we're learning about the arithmetic ones right now is because when they do plus 2, plus 2, plus 2, that was just like your stacking cups, right? And when you looked at your data for your stacking cups, what kind of shape did it make when you plotted the points? A line, okay? That makes sense. If something has a common difference of 2, meaning every time I go over 1, I go up 2 higher, over 1, up 2 higher, over 1, up 2 higher, it makes sense that it's going to make a line. So these arithmetic sequences mesh really well with our linear equations because they basically kind of have a slope, right? Every time we move over a term in the sequence, we move up or down the same amount being added or subtracted. If we start doing multiplication, that makes a different type of pattern and a different shape. And so those ones are actually called geometric. Okay? So these ones are only if it's added or subtracted. And that amount that we add or subtract, we call this the common difference. Okay? So instead of keep saying the amount that you keep adding or subtracting, that's too much for mathematicians. Yes? Arithmetic sequence. So a sequence is any list. Pattern, no pattern, crazy pattern, whatever. To be an arithmetic, you have to have a pattern that is specifically addition or subtraction of the same amount between the terms. So every time you add 5, or every time you move to the next one, you subtract 10. Okay? That good with everybody? We understand the vocab? All right, so we're not going to be able to get through this example because you guys are done in like a minute. But so what we're going to do, don't freak out. I kind of planned for this. Do you see? You don't have the next homework assignment up there. You just have the review and the syllabus page because I know we're not going to finish and you won't be assigned the homework on this until Monday night. Okay? Does that make sense to everybody? Okay? No anxiety about this, all right? I'm not leaving you hanging. I promise that you'll get the stuff that you need. So there's 3 examples for this section, which we'll complete when you come in on Monday. We'll also do something else, a different kind of investigation. But Monday night for homework, you will just do homework on sequences, okay? Specifically the arithmetic kind, all right? Everybody okay with the vocabulary? And we'll talk more about this on Monday? Yeah.